So let's start writing the solution to this problem. We will be needing a graph. So I've taken this class as graph, and in this graph we will be needing number of vertices and number of edges. So V for number of vertices and E for number of edges. Now we're gonna be needing array that can store all the edges along with the information, and this edge itself is a class. So let's create this class edge, and here we will be having the source vertex of this edge, the destination vertex of this edge, and the weight of this edge. Let's say W. Now let's create the constructor for this edge class to define these variables. So let's create this constructor, and we're gonna initialize all these variables with 0. D 0. So we have created the edge class, which will be holding the complete information about the edge. Now we have to construct the graph, right? So let's create the constructor. This constructor will be having V and E as the input parameters. V is the number of vertices and E is the number of edges, right? So let's take int V and int E, and now let's define these. This dot V is V and this dot E is E. Oh, let's change this to E. Now let's initialize the edge array, and the length of this edge array will be equal to the number of edges in this graph, right? So now let's, after creating this edge array, we need to initialize each cell with a new edge object. So it is going to go till E, and here inside this for loop we're going to initialize each cell with a new edge object. So new edge. Now going to the main method, here we're gonna create a graph G equals to new graph, and in this constructor we will pass V and E, that is number of vertices and number of edges. So number of vertices is 6 and number of edges is, let's say, 9. Now let's say A is the 0th vertex, A equals to 0, and B is the first, to 1, C is second, D is third, E is fourth, and F is fifth. So now for the first edge AB, we're gonna set up the values of source vertex, destination vertex, and the weight. So A is 0, B is 1, so the source vertex is 0, edge 0, as this edge is present at the 0th index. So the source vertex is 0 and the destination vertex for this edge is 1, and the weight of this vertex we have taken, or we've been given, is 8. So weight equals to 8. Now the next vertex is AF, which is present at the first cell. So for AF, the source is 0 and the destination vertex is 5. So 0, 5, source is 0 and D is 5. And the index is 1 and the weight is also 5. Now the next edge is AD. Let's copy this and let's edit it for AB. This is the second cell and the source is 0 and the destination is 3. Second cell. And the weight is, let's say, 3. So now without wasting much time, let's paste all the other edges. So these are the total 9 edges that we have in our graph, and now we're going to call Bellman-Ford method And in this method, we're going to pass this graph and the source vertex. Source vertex is the 0th vertex, so we're going to pass 0 here. Let's create this method. And in this method, we're going to take an array to store all the distances. Let's change this to source. And let's take the int array, int array distances, or dist equals to new this int array. So the size of this int array will be equal to the number of vertices, right? So because we're gonna store the distances for each vertex from the source, right? So we're gonna fetch it from the graph and we're gonna pass it here. Now let's take a for loop to initialize all the vertices distance with infinity. And for us, infinity is integer dot max value, right? So we're gonna initialize all the vertex or all the distances for the vertices with infinity or integer dot max value. So distance of I is equal to integer dot max value, and the distance of source from itself is 0, right? So for source s, it should be 0. So we have initialized these distances, and now we have to relax the edges for n minus 1 time, right? And in our case, n minus 1 is v minus 1 because v is the number of vertices, right? So let's take a for loop for I equals to 0 till v, and the inner for loop for e for edges, because we have to go through each edge for v minus 1 time. So for e, we have to fetch it from g. So this should be plus plus I, and this should be plus plus j. So we're gonna first increment it, and then now we're gonna fetch the values for u, v, and cost, u, v, and c. U is the source vertex, right? So this is u, int u, and v is the destination vertex, so int v is g dot edge j dot d, and the cost is the weight of the edge, so c is e dot edge j dot w. So now we're going to apply the Bellman-Ford formula. First, we're going to check that du is equal to max value or not. It must not be equal to the max value. So distance of u must not be equal to max value, and then we're going to check that distance of u plus the cost uv plus c is less than dv or distance of v or not. So if it is less than distance of v, we can relax it and we can update the value for distance v. So distance v will be then equal to this sum. That's it. Now the only thing we need to do is to check for negative cycles. So if there is a negative cycle in the graph, we're going to print that the graph contains negative cycle. So after the execution of these for loops, we will be having the optimal solution, right? But even after the execution of these for loops, we're not having optimal solution, or we are able to get the shortest distance using this Bellman-Ford formula, then obviously there is a negative cycle involved. So what we're gonna do, we're gonna copy this code and let's paste it here. If we still get this equation true, that if still the distance of u plus c is smaller than distance of v, then we're gonna print that this graph contains negative cycle. So let's print it here. Sys out, the graph graph contains negative cycle. That's it. Now we just need to print the values or the distances from the source to each vertex. So let's take a for loop to print the values. So taking it starting from I, and it will go all the way to v minus 1, and here we're gonna print I and di, the corresponding distance. So plus di, distance I. So now the implementation is complete. We just need to run this program to test this. So let's run this code, hit the run button, and see this is the result. A to A distance is 0, A to B is 1, A to C is 4. These are the shortest distances from A, because A is the source node. So this is how you can solve this problem using Bellman-Ford to find out the shortest distances of each vertex from the source.